Hello, our esteemed viewers and subscribers. Welcome to this video on statistics, where we'll be looking at mean, median, and mode of grouped data. Our problem here is calculate the mean, median, and mode of the distribution. And this is a distribution of a group of ages contained in the first column, and their respective frequencies are also in the second column. We are going to start the solution from the mean, which gives the formula sigma fx over sigma f. By f, we mean the frequency, and the x is going to be the mid values of the class intervals, which means we are going to have two more columns, x and fx. To calculate the mid value, the best method is to add the lower limit and the upper limit and then divide the sum by 2. Starting from the first class interval, 1 plus 10 gives 11. 11 divided by 2 gives 5.5. 11 plus 20 gives 31. 31 divided by 2 gives 15.5. 21 plus 30 gives 51. 51 divided by 2 gives 25.5. 31 plus 40, divide the sum by 2 gives 35.5. 41 plus 50, then divide the sum by 2 gives 45.5. The next is fx, multiplying the frequency by the made value. 2 times 5.5 gives 11. 4 times 15.5 gives 62. 6 times 25.5 gives 153. 5 times 35.5 gives 177.5. 3 times 45.5 gives 136.5. We then go ahead to sum two columns, the f column, which is sigma f, and the fx column, which is sigma fx. Summing up f, we have 2 plus 4 plus 6 plus 5 plus 8 giving us 20. 11 plus 62 plus 153 plus 177.5 plus 136.5 gives 540. Substituting into the formula to obtain the mean, we have 540, which is sigma fx, divided by 20, which is sigma f. Carrying out this division, we have the mean of the distribution to be 27. We then go ahead to calculate the median. The formula for calculating the median is given as Lm plus open bracket sigma f over 2 minus CFBM all over Fm, close the bracket, multiply by W. The Lm means the lower class boundary of the median class. Sigma f is the sum of the frequency. We divide it by 2. CFBM means cumulative frequency before the median class. Fm means the frequency of the median class, then the W means the class width. So from here, we are going to create additional column, which is cumulative frequency, that is accumulating the frequencies. The cumulative frequency of the first class interval will still maintain 2. Then we now add this 2 to this 4 to give us the next cumulative frequency. 6 plus 6 gives 12. 12 plus 5 gives 17, and 17 plus 3 gives 20. This 20 must always tally with the sum of the frequency. So the next thing is to identify the median class. Since the total population of the distribution is 20, to obtain the median class, we divide 20 by 2, and that's going to give us 10. Since 20 is even number, it means the 10 and 11 will be within the median class. So we then check the cumulative frequency and see where 10 and 11 are accommodated. They are accommodated here. Therefore, the median class is 21 to 30. From there, we will be able to calculate the lower class boundary of that median class. To do that, the upper class interval here, which is 20, will be added to the lower class interval. 20 plus 21 gives 41, divided by 2 gives 20.5. Therefore, Lm, which is the lower class boundary of the median class, is 20.5. The next is sigma f over 2. our sigma f is 20. 20 divided by 2 gives 10. Then the next thing is cumulative frequency before the median class. The median class is here and the cumulative frequency of the class before it is 6. Therefore, the cumulative frequency before the median class is 6. The next is the frequency of the median class. The frequency of the median class is 6. Then the last is the class width. The class width here means how many items do you have within this interval? 21 to 30. There are 10 items. Or another way of doing this is to find the difference between the class boundary. The class boundary here is going to be 20.5 to 30.5. So 30.5 minus 20.5 will still give us 10. So having gotten all these values, we are going to substitute into the formula to have our median. So substituting LM is 20.5. We have it as 20.5 plus our bracket sigma fx divided by 2 is 10. So we have 10, then minus 6, which is cumulative frequency before the median class. Then divide by the frequency of the median class, which is 6. Close the bracket, multiply by 10. Imputing this in our calculator, we are going to have it as 27.2, representing the median of this distribution. We then go ahead to calculate the mode. We have the formula for the mode to be LM plus delta 1 over the sum of delta 1 and delta 2 multiplied by W. The LM is the lower class boundary of the modal class, and the delta 1 is the difference between the frequency of the median class and the class before it, since the distribution is arranged in ascending order of class interval from 1 to 10, 11 to 20, and so on. But if it is arranged in descending order, you have the option of rearranging it in ascending order, then you solve this way. Or you pick the delta 1 to be the difference between the modal class and the class after it, and delta 2 to be the difference between the frequency of the modal class and the one before it. So let's go. We have to identify the modal class. We check the frequencies. The highest frequency there is 6, and the class that has that frequency is 21 to 30. So the lower class boundary of the modal class now will be from here 20 and 21. Sum it up and divide by 2. We have it as 20.5. Then delta 1, the frequency of the modal class is 6. 6 minus 4, that's the frequency before it, is 2. Then the next one, which is delta 2, the frequency of the modal class is 6 and the one after it is 5. 6 minus 5 gives 1. Then we have the class width. The class width, we borrow it from our median class, is going to give us 10. So we substitute all this into the formula to calculate our mode. LM is 20.5. Then the delta 1 is 2. Then delta 1 is 2 plus delta 2, which is 1. Then multiply by 10. Inputting this in our calculator, we have the mode to be 27.2. And that's all for the solution of this problem. And this is where we are ending this tutorial. Thank you for watching. Please like and share this video. Also remember to subscribe to our YouTube channel. See you in our next video. Bye for now.